All right, in the interest of time, I'm going to go ahead and introduce our next speaker. Our next speaker is Dr. Nicholas Gabler, and he is an associate professor in the Department of Animal Science at Iowa State University. His research and teaching has been focused on fundamental swine nutrition, metabolism, and physiology. He obtained his bachelor's and PhD degrees from La Trobe University in Melbourne, Australia, and upon completion of his PhD, Dr. Gabler conducted postdoctoral research at Purdue University and then Iowa State University. In 2008, he joined the Animal Science Department at ISU as an assistant professor. Presently, Dr. Gabler has an active and diverse research program that focuses on understanding and improving swine feed efficiency, growth, and intestinal physiology and health of swine. He is also actively researching the effects of pathogens and nutrition on pig performance, intestinal function, and integrity, metabolism, tissue accretion, and health. And his talk today is entitled Metabolic Adaptation to Disease in Pigs.
Okay, thank you, Carson. So, good afternoon, everyone, and thank you very much for coming to listen to my presentation. And thank you to the committee for asking me to give a bit of an overview of some of the work that we've been doing in our lab for about the last 5 years or so. So it's been about 2 or 3 years since we last presented some stuff here. And so, really what we've been working on is we're trying to understand how to best manage and feed health challenged pigs. And then we've tried a few different nutritional strategies, and then we always came back to the point where no matter what we tried from a nutritional intervention, we didn't really have that much luck at actually getting pigs to grow better or improve the feed efficiency of those pigs. So then over about the last 3 years, we then changed our tack, and then we want to look at, okay, what is the metabolic profiles of those pigs? And then is there an opportunity then that we can come in and actually mitigate that or augment a certain pathway to actually help those pigs grow through the challenge? So the first thing I want to say is we are not trying to stop the immune system from working. The immune system is actually very important for the pig. It's critical for survival in the face of a pathogen challenge. But the pig has to be able to build tolerance through its adaptive or innate immune responses to actually be able to grow through and actually thrive in an environment where there's continuous pathogenic challenges. And so if the pig is actually stimulated with an immunological challenge, whether it's from a pathogen or an inflammatory related agent, what it does, it leads to partitioning and nutrient alterations in the pig. And one of the big things that we've seen, it leads to anorexia, as well as there's an increased demand for acute phase proteins, immune cell production, which then is partitioning energy and amino acids away from lean tissue growth. But the other important aspect of a general immune challenge is actually going to be the febrile response. And so the febrile response can actually be very energetic. And all this is going to lead to an increase in the catabolism of lean tissue. And so what we're really interested in is the ability of the pig to allocate resources or repartition resources between lean tissue deposition and also the immune response, and finding that happy medium where it can actually grow through an immune challenge and actually do better in the long run. But the problem that we have within this system is that the pig and also us humans, we're engineered to actually prioritize functions to the brain, the immune system, over adipose and muscle tissue growth. So in other words, during an immune challenge, the pig is actually going to put more resource into maintaining brain function, immune function, than it is in actually lean tissue deposition. So we want to find a happy medium where we can actually support lean tissue growth during the face of an immune challenge in growing pigs. And so one of the questions our group's been asking is, how do certain pathogens that are applicable to the swine industry alter nutrient partitioning, tissue accretion, and also metabolism in growing pigs? And so today, for about the next half hour, we're going to talk about some work that we've been doing with PRRS, PEDV, Lawsonia, Mycoplasma hypomoniae, and also some swine influenza. And so the majority of this work has been published or is about to be published. And so what we see with PRRS, this is some work we did with National Pork Board and Choice Genetics, would have been about 4 years ago now, is that if we challenge pigs at about 30 kilograms body weight, we can decrease growth rates, feed efficiency, tissue accretion by 17 to 20% compared to our control kind of PRRS naive pigs. But we don't alter fat deposition, there's no real partitioning difference between fat and lean. Most of them actually decrease at the same rate, so in that 17 to 20% range when we look at the body composition, tissue accretion, and we have an impact on feed efficiency. But more importantly, if we want to extend that out all the way out to market, what we did with these pigs, we added an extra 14 days or 2 weeks onto their marketing to get them to the same weight, the same carcass weight. And then Wes Schwer, who's in the audience, he estimated this to cost about $3 to $30 per pig in this production setting back at this time. And then we all know that PRRS, from Holkamp's work, that PRRS is a very economically significant kind of pathogen to the industry. But in a grow finish pig, we estimated, as well as the patient's lab as well, in that $3 to $30 per growing pig space is what it cost. And it had a longitudinal impact on these pigs when they were challenged at about 30 kilograms. And so one thing that we're not interested in just looking at a 2-day pathogen challenge. We want to know longitudinally over a couple of weeks what's actually occurring. Emma Helm recently published some work out of our lab, part of a master's program, where she actually did a dual challenge with Lawsonia and Mycoplasma hyemoniae to some growing pigs. And these pigs were about 65 kilograms at the time, and over a 6-week period, we see about a 17% reduction in average daily gain, about 11% reduction in average daily feed intake, and about a 7% difference in feed efficiency in these pigs. And then tissue accretion was all affected, but there was no difference between lean deposition and fat deposition or bone deposition in the sense of how they were partitioning their nutrients. It was just reduced to the same extent across the board. Then about in 2015, just after PED occurred in Iowa, we were really interested in understanding how does PEDV actually impact nursery pigs. At the time, everyone was focused on just looking at suckling pigs during lactation and with the high mortality, but what you want to know, is there a carryover effect or is there an issue with a nursery growing pig? And Shelby Curry's part of her PhD did some extensive work trying to understand how does different coronaviruses actually impact feed efficiency and growth performance in PED infected pigs. So in this case, we started off with a 10 kilogram pig, and we can see across the board here we have about a 16% reduction in average daily gain and about a 27% reduction in feed intake, but we saw no differences in feed efficiency. We've repeated this type of work a couple of times in nursery pigs, but generally what we see is that we don't see major mortality with our PED infection model in these nursery pigs. We mainly see that actually in a suckling pig. They just have the tissue reserves and energy reserves to actually grow through this enteric challenge. And again, tissue accretion pretty much reflects average daily gain. Just a significant reduction of about 16% or so across the board with regard to lean and fat deposition in these pigs. So in other words, what we're seeing with either PRRS, with PED, with Lawsonia, and Mycoplasma dual challenge, we get a significant reduction in growth rates as well as feed intake, and depending on the pathogen and depending on the severity and the duration of the actual pathogen or pathogenesis is whether or not we get an impact on feed efficiency. More recently, Wes Schwer got a hold of some data that was from Dr. Geiger and NutriQuest has lent us, and then we're trying to understand or show what does a swine influenza challenge do to feed efficiency and growth rates in pigs. And so thank you to NutriQuest for letting us kind of play with this data set. But what it is, they challenged some 7 kilogram pigs for about 28 days. And then across the board, they see about a 7% reduction due to influenza of growth rates and about 11% reduction in average daily feed intake over 28 days. And then feed efficiency over this 28-day period was reduced by about 14%. If we just look at the first 5 days of this influenza challenge, these numbers are a lot higher and it's more significant. So in other words, during that peak influenza kind of period, we see a major actually impact on, a more significant and severe impact actually on feed efficiency and growth rates. But again, all these pathogens seem to have a longitudinal or a long-lasting impact on the pig. So it's no point just looking at it just within 2 days or in a 4-day kind of shedding window or challenge window. They're having a long-term impact on these pigs and it can have an impact all the way through to market. And I will say that on our tissue accretion and growth rate data, we've done some other work with PRRS, and it really depends on the genetics of the pig and the severity of the challenge, whether or not we actually see compensatory growth. When I first started doing this work about 5 years ago, Wes and I used to talk about compensatory growth. We didn't believe it. But in our first study where we saw 114 days extra to market compared to 110 days, we didn't see compensatory growth. But when we did it with some mash-off pigs, different genetics, and then what we did with some maternal line choice genetic gilts, we actually saw that those pigs actually came back at the same time to the same growth rate, and there was some differences in feed efficiency that got them there. So in other words, we can have immediate impact, and then compensatory growth from a genetic standpoint could be an opportunity to actually try and recover and make these pigs actually get to market in a similar time as a healthy control pig. The other facet of our research program that we've done a lot of extensive work in is intestinal function and integrity. And we're trying to understand, does an enteric challenge or a respiratory challenge or a systemic challenge, does it impact the intestinal epithelium, particularly the small intestine? Does it impact it the same way? And this is some part of Wes Schweer's master's work. This is quite a few years ago now that we did this work. But really what we're interested in, we had a control group of pigs that we had at BSL2 facility here at the vet school. We had a PRRS challenge group for 21 days. We had a PED challenge group for 7 days. And then we had a PRRS challenge group for, well, actually 21 days. And then the last week, so on day 14, we challenged them with PED. And the point I want to make here is, depending on how or what the challenge is, whether it's kind of more of a systemic respiratory challenge in PRRS versus a PED or enteric challenge, we do have a differential impact on the intestinal epithelium and the ability of that intestine to actually handle and absorb nutrients. So here, Dr. Schwartz at the vet school did some lesion scoring for us. He was blinded to these treatments. But as we have a combination of pathogen challenges, our lesion scores go up. There's mild or more moderate villi atrophy, fusion, mild infiltrate, so we had a score of about 4 over these sections. You can see PED really just cause a blunted, attenuated villi tips and slothing. And then PRRS looks very similar to what we see, whether in the jejunum or ileum, looks very similar to what we see within our control pigs. So in other words, a PRRS infection in this study, we do not see any differences in intestinal architecture. The morphology is the same, and even lesion scores, we don't see any major immune cell infiltrates, etc. within these. One thing that we have that Shelby Curry and Wes Schweer have highlighted with both PED and PRRS challenges is that during a PRRS challenge, the metabolic machinery to absorb glucose seems to be upregulated in small intestine of pigs compared to control pigs. But in PED, we see glutamine and amino acid transport all upregulated. And we've been able to actually recover the intestinal epithelium and reduce it by just promoting luminal amino acid kind of aspects to actually help rebuild and restitute this intestinal epithelium. And the pig is not actually mobilizing a lot of resources either from the liver or from the muscle to actually help with this rebuilding during PED. It's obtaining most of those nutrients from the lumen with the regeneration aspect. So from a nutritional strategy to actually help rebuild and restitute a damaged epithelium through whether it's a rotavirus or some other bacterial challenge, there's opportunities from a nutritional standpoint to actually help supply the nutrients and energy needed to actually rebuild this within about 5 to 10 days. So really what we've seen with our, this is not all the pathogen challenges that we've done over an extended period of time, but really what we see is that, in particular with PRRS, we see that PRRS alters nutrient partitioning in the sense that it just reduces lean tissue deposition, reduces fat deposition and bone deposition. And this is whether we're using a 118-4, a 174, a 134 strain of PRRS or open reading frame of PRRS, we get similar results. However, the severity and duration can differ between the type of PRRS that we actually have used. But more recently, what we've been trying to do is, to what extent does actually just the reduction in feed intake or the anorexia during a pathogen challenge explain a lot of this metabolic phenotype? And so is it pathogen that's actually driving the reduction in growth performance and feed efficiency in some of these challenge models? Or is it actually just simply the pig doesn't consume enough energy and amino acids and other nutrients? Therefore, does that drive the phenotype that we're seeing? So where is our opportunity here? And so what we've been doing, part of a USDA grant that I've been working on for the last 3 years with our lab group and others, we want to determine how PRRS virus modulates nursery pig growth performance, tissue accretion, pre and post absorptive metabolism and energy utilization. But more importantly, this is what we're going to focus on is the second part of this, is we wanted to define the role of just reduced feed intake or disease anorexia and how much does it describe the reduction in pig performance that we've seen in the context of a PRRS challenge. And so I won't say too much about the top part, but really our working hypothesis for this work was this, is that a healthy pig will consume feed ingredients. Thanks Wes Schweer for this slide. And then what we see is that they absorb carbohydrates and amino acids, and if everything's working well, we've got efficient nutrient digestibility and nutrient transport, goes to lean tissue deposition. That's the ideal situation that we want. Pig consumes the energy, the feed, the nutrients, amino acids, and then it's efficiently translocated to muscle and to bone and adipose tissue to allow for growth rates to occur, or optimal growth to occur. However, during a pathogen challenge, we have a reduction in nutrient intake to start off with. We have an increase in energy needs for the febrile response, immune cells, so T cell, B cell replication, antibody production, cytokine production, acute phase protein production. But if there's not enough amino acids or energy coming from the diet to actually support that, then the pig is actually going to take it off its back, literally. So our hypothesis was there would be an increase in reactive oxygen species and muscle proteolysis to liberate amino acids that could then go to the liver to support both gluconeogenesis for the immune system to work on and the febrile response, as well as providing amino acids for an incorporation into the immune system components. So that was our working hypothesis that we wanted to test with this study. And then Dr. Bumgard and our group in different types of study models, we've shown that there is an increased glucose requirement during an activated immune system response. But then how does the pig get to that glucose? Can it come from the diet? Does it produce it through gluconeogenesis? Does it get it from amino acids, glycogen stores? Because the pig has to be able to get it. And one thing that we've actually tried to do is actually in an old Iowa Pork Producers Association study, we actually tried to provide extra glucose through the water or top dressed in feed, as well as some other nutritional components. And we were not able to rescue that PRRS infected pig with regard to growth performance or feed intake. So in other words, when we provided exogenous or say extra glucose for the pig to voluntarily take in, we couldn't get a difference in growth performance or feed intake. Now, if we IV'd it into the pig, which is not practical from a commercial production standpoint, then we may have some beneficial effects with regard to the immune system and preserving lean tissue accretion. So the general methods of what we did for this study, it was all done in a BSL-2 facility just across the road here, or down here now. We had 72 naive gilts, so about 11 kilograms body weight. We blocked them by body weight across 3 treatments. And so each block was within about 200 grams or less of each other, each block of 3. And we allocated them based on body weight to an ad libitum control PRRS naive pig, a PRRS treatment where we inoculated them with a 134 open reading frame, This is an isolate of a PRRS isolate that we actually obtained through Iowa Select. And then we had a treatment that we actually pair fed the day behind the PRRS infected pigs. So in other words, if our PRRS pigs on day 1 ate 500 grams of feed, on the next day we gave the ad libitum, the pair fed pigs, we gave them that same amount of feed. And every day we gave them exactly the same. So what we tried to do is calorically match the intake the best we can between the PRRS pigs and a PRRS naive pig to end up with the same caloric intake. And so it's a pair feeding model that Dr. Bumgard has perfected in dairy cattle, and also he and I have done some stuff in pigs with it. So all the pigs are fed the same diet, it's just a corn soybean based diet. And then what we did, we had a 35-day growth study. So we're interested not just in the first week of a PRRS challenge, but over 5 weeks, what was happening. We did weekly performance, we had daily feed intakes, daily body temperatures were taken to understand what's going on with the febrile response. We also looked at total tract digestibility at a couple of different time points to see how digestibility was affected. Because one of the things that if we do see differences in digestibility coefficients in a health challenged pig, is it due to the fact that there's different rates of passage? Less feed coming in, are they just more efficient? Or how does the amount of feed actually impact that? And then we necropsied some pigs at day 9, 10 or day 16, 17. We have the 9, 10, 16, 17 here because our pair-fed pigs were 1 day behind technically, so that's how we're classifying them. And then we also did body composition scans because we want to know for the same caloric intake, are we getting the same deposition rates of lipid and protein that are what we would with our PRRS infected pigs. So just to show what was going on with our viremia, our PRRS naive ad lib control pigs and our pair-fed pigs were all negative for PRRS throughout the test period. And then we can see by about day 4 we get a reduction in CT value. In other words, we get pig viremia in the blood. And then these pigs by 35 days were coming back up, but they were still shedding live virus, or still shedding virus based off of CT values. So in other words, they're still viremia. Antibody response, by about between day 4 and 7, we see an elevation in serum antibodies. And then our PRRS naive pigs, whether it's pair-fed or restricted fed, they didn't have any PRRS antibody. So in other words, the BSL-2 system that we used was adequate, did the job. We kept our 2 naive treatments clean of PRRS, while our PRRS pigs actually were nicely infected with this PRRS virus. And we did an IM and an intramuscular injection on these pigs when we inoculated them at day 0. So Carson DeMille, one of my PhD students who introduced me, this is what her job was, to do daily feed intakes. And so every day she went in and she measured the feed intake of the PRRS pig, and then the next day she fed the grey bar here, the the pair-fed pig, the same amount of feed. So you can see these lines are quite close to each other. And then these black dots here are actually our weekly feed intakes for our ad lib pigs. We can really, by about day 3, day 4, we really start to see the phenotype of PRRS post-infection. In other words, these pigs get wiry, they kind of get more gaunt, they go a bit more anorexic, and you can, by about day 9, 10, we actually get our reduction in feed intakes at our lowest, and then by day 35, feed intake is pretty close back up to where our ad lib control pigs are. Another thing that we're interested in is the energetics associated with the febrile response. And unlike most febrile response work has actually been done with endotoxin or LPS, and that's normally just give a pig a challenge, and then within 6 to 12 hours, their body temperature is going to be pretty close back to baseline. So what we did here, we just went in every day, we microchipped these pigs with a biosensor, and then we had a paddle that we would go in and scan each pig every morning. And this is our morning body temperature, core temperature of these pigs over 35 days. Our red here is our PRRS pigs, our black is our ad lib control pigs, and then our grey bar here is actually our restricted fed or pair fed pigs. You can see by about day 3, day 3, 4, we start to see a nice elevation in core temperature in the PRRS infected pigs, but then at the same time we see a decrease in body temperature in our pair fed. And that's probably due to the thermic effect of feeding. There's less feed there, less fermentation occurring, so we actually get a reduction in in body temperature. So if we look at the average over this period, our ad lib control pigs, healthy pigs, were about 39.5 degrees centigrade on average their temperature, and there was about 0.3 to 0.4 degree increase in core body temperature on average with our PRRS infection, and it was about nearly a degree lower in our pair-fed pigs. If we look at the overall performance of these pigs over 35 days, and I forgot to mention, these are our N's of 8 in each treatment here. We can see that feed intake reductions were about 51% between our PRRS and our pair feds compared to the controls, and then average daily gain was about 58%. So this reduction in at least in growth rates and feed intake was a lot more severe than what we saw when we did some work in the field. But by design, we actually had the same amount of feed intake on average over the 35-day period, and then we didn't affect between our pair fed and PRRS, we did not have an impact actually on average daily gain. So the same caloric intake, we got similar rates of gain. And then this resulted in no difference in feed efficiency between our 3 treatments over the 35-day period. So these are our pigs at 35 days. This is just prior to euthanasia. You can see here's our PRRS infected pig, here's a pair fed pig, and here's our ad lib pig. So we're really looking at about 15 kilogram lighter pig just over 35 days with this challenge. And then what we really see with this, we broke out some of the organs and organ weights, and what we see, PRRS pigs had a larger lung and heart mass, which makes sense. The lungs are more consolidated due to the PRRS compared to our control pigs or our naive pigs. But the pair-fed pigs had a greater large intestinal mass compared to our PRRS infected pigs. And that's just due to the fact that they're probably trying to compensate for reduced energy by increasing fermentation. So there is some differences between organs with regard to how the disease as well as the metabolic restrictions actually altering the pig. If we look at tissue accretion rates, we longitudinally scanned these pigs with a DEXA machine like we've done with our other studies. And like what we reported in PRRS in probably about the 4th slide, we see a significant reduction of about 30 to 60% in tissue accretion rates. And between the pair-fed and the PRRS pig, we see no difference in lean or fat accretion rates in these pigs. So in other words, they're kind of handling the caloric restriction the same way, whether it's anorexic-induced voluntary feed intake reductions or a forced reduction in voluntary feed intake. So this is probably some of the interesting stuff, or other aspects that we tried to look at with this study is what is the energy cost of the PRRS disease? And so does PRRS alter metabolizable energy utilization within these pigs? So to do that, there's a few assumptions we had to make, as well as we have individual data on all of our pigs. And so what we have here, we had Carson determined digestible energy for each of these pigs, 8 per treatment at days 5, 9, 13, 17, and DPI 25 to 29. We averaged these DE numbers that we got for each pig. We then converted it to ME using Noblet and PRRS equation. So we then had ME intake for each individual pig. We had average daily feed intake on these pigs over this 35-day period, and we also had lipid and protein deposition rates over these periods of time. And so what we can do is if we take the assumption that it takes 10 kcal of ME per gram of protein gain and takes 11.7 kcal of ME per lipid gain, whatever's going to be left over based on this should be the difference between actual ME utilized for maintenance and other processes versus the disease response. And so by doing this math on an Excel spreadsheet, these are some of the numbers that we came up with. So everything's on a kcals at ME intake basis, And what we see here, our libidin pigs were consuming about 4,400 kcals per day of ME. Our pair-fed and PRRS pigs were doing about half of that, so they were around that 2,200 kcals. The actual ad-lib pigs were using about half of that, or 2,300 kcals for other purposes. They used about 1,000 for protein deposition and 1,100 for fat deposition. And then you can see the numbers here for our pair-fed and PRRS infection. So to make this a little bit easier to understand, we then expressed this actually on the percentage of ME intake. So the amount of ME intake, if this equates to 100% for each of them, 22% of the ME intake on ad-lib pigs was utilised for protein deposition, compared to 21% for our pair-fed pigs and 19% for our PRRS-infected pigs. If we look at lipid deposition, 25% of the ME intake was utilised for lipid deposition, compared to 21 and 19 for our PRRS-infected pigs. And then what was remaining was 53% was used for maintenance and other purposes. So maintenance and other purposes could be the immune system, could be activity, it could be thermogenesis, etc. It's kind of a catch-all category that we can't define, or we haven't defined. Then what we see, a pair-fed pig uses about 58% in this category, and then our PRRS pig had about 42% of its ME intake was utilised due to this. So the difference between our PRRS and pair feeding equated to about 150 kcals of ME intake per day. So we can kind of crudely estimate, and this is napkin math, that we've tried to correct for as many things as we could. So we've corrected it on individual pig DE values, on individual pig feed intake, individual pig growth, individual pig lean accretion or protein accretion and fat accretion. So we tried to account for all these differences. So we estimated that just PRRS alone is costing about 150 kcals of ME intake a day over this 35-day period. But during peak infection, where we actually have about a 1 degree difference in body temperature between our pair-fed and our PRRS pig, this number could be a lot higher. It could be up to 3 times higher than this. So it depends on where you slice your pies, depending on what the metabolic application or implications are going to be. So some other data. I've put these pictures in just to show you in between pig viremia and seroconversion. This is what's going on with our pigs. This is at day 16, 17. So this is close to where we have peak febrile response differences between our pigs. Here's our ad-lib control pig up here. We have our pair-fed pig here, and this is our PRRS-infected pig. So over 16 days, our PRRS pigs, over the first 16 days post-challenge, are virtually not even growing. So this is typical, probably what we would see actually out in the field. Where our pair-fed pigs are still growing at they're doing about probably 100 grams a day, compared to about 400, 500 grams a day for our control pigs. This is in the first 16 days of the challenge. So this is a lot more severe phenotype than if we dilute it out over 35 days. Feed intake, about 400 grams a day of feed intake compared to 800, so still that 50% reduction. And then we do have feed efficiency differences. And this is what their loin muscles look like. Just looking at the cross-sectional area, you can see that the feed efficiency average daily gain is reflected just within these loin eye areas. And this is just crude demonstration, but you can see our ad-lib muscles about twice the size of our pair-fed, and then even the PRRS loin areas are actually a lot smaller, but we never truly quantified it. And then you can see the lungs are more consolidated and darker here in our PRRS pigs compared to our ad-lib and pair-fed pigs. So what this data suggests, and a lot of our challenge data suggests, is that appetite may explain most of the phenotype that we're observing within the pigs when they're undergoing a pathogen challenge. So what can be done? And this is the question that a lot of us are asking. So what can we actually do when we got voluntary feed intake is going to be reduced? In other words, the pigs are undergoing anorexia. Is there anything that we can do? And I can't give you a straight answer that yes, we can do A, B, and C and not X, Y, and Z, but we are trying a few different things. And then under the assumption that the pig doesn't want to eat the full amount of feed that it needs to grow, similar to a healthy pig. So what we've been doing, this was a pork board project that with the mash-offs that we finished up about a year ago now, that Wes Schweer did, but we want to look at, can we alter the lysine to energy ratios or requirements of the pig in the face of PRRS? In other words, if the pig is eating less, can we get more units of amino acids in per unit of energy, and then does that have a different breakpoint than a control pig? And we're still we're going through some of this data, but generally what we see here, this is our healthy PRRS naive pigs. This is based on average daily gain. Here's our, we've got our, what do we have, 6, 7 points, breakpoints here of lysine to energy ratios. About the third point in this case, about 0.5 here. Our third one is close to about 100% what we predicted. And really what we're seeing under PRRS, even though growth rates are lower, the breakpoint is breaking further to the right. In other words, to the right-hand side of 100% in the face of PRRS. So there we did this, we repeated this about 3 different ways. We did it with two sizes of the pig, and then also our control barn in one of our studies broke with PRRS when we did this study, therefore we had a natural infection. And then really we looked at both a one slope and a quadratic equation for breakpoint analysis, and if we just look at the averages of where they intersect, this is kind of what we're predicting may occur or may be optimal with regard to lysine to energy ratios for these pigs. And we can give you more data about this work after the talk. But really what we're seeing, generally speaking, whether it's a 25 kilogram, 50 kilogram pig, whether it's an experimental infection or a natural infection, we're generally seeing that our lysine to energy breakpoints are shifting about 110 to 120% of requirement. So a little bit to the right. Now, depending on the severity of the actual challenge, some of them actually didn't even break. So if we did on these star ones here, it was linear all the way through. And so we probably have to have more numbers to actually really truly find the breakpoint. But really we're seeing about 110 to 120% of requirement. And we see similar, whether it's everyone's infected at the same time, that's experimental infection, or a natural outbreak where the control barn naturally broke, we're seeing the same kind of relationship with our breakpoints. We use soybean meal as part of our diet due to trying to make it more industry applicable and the cost. And so it's hard to differentiate whether this breakpoint is due to differences in crude protein, essential amino acids, or non-essential amino acids, and that needs further validation. But I will say we have conducted, Wes and I have conducted about 3 different types of PRRS challenge work with soybean meal, and we do not see any benefit of high levels of soybean meal in our pigs. And that goes against some of the kind of anecdotal industry kind of data that's out there. We increase our soybean meal, we'd have to get up to about 40% in the diet before we would see actually a benefit in a growing pig that is challenged with PRRS. And that's just probably not practical from a nitrogen balance standpoint. And so we don't see a true benefit of soybean meal or the crude protein aspects there. So in general conclusions, we know that appetite seems to be the biggest factor that is reducing performance of across all of our models. And we particularly see that when we match it as best we can with a caloric restriction or a pair-fed model. So really for us, we think appetite, or this is my opinion, I think my group may agree with me or they can disagree, but my group would suggest that the opportunity to help a pig recover or grow through a pathogen challenge is going to be centered around targeting that pig to eat more during that challenge period. Now there's data out there in rats that say that if you force feed rats a bacteria, listeria, you're going to kill them, but you do not see that with viruses. So there could be a difference with regard to trying to promote appetite in the face of virus versus bacteria, and that really needs to be done in pigs, not in rodents, because it's not going to be exactly the one-to-one translation. And so I think there's opportunity to try and promote appetite during mild or subclinical disease. Now what that actually will be, well, I'm not quite sure yet, but there's some opportunities there. This work to date that we conducted with this pair feeding study back in the spring, we're estimating about 150 kcal of ME intake per day is what the PRRS is actually costing alone, above and beyond the actual reduction in feed intake. Other work that we haven't gone over, we did look at a lot of proteolysis differences in lean tissue, so in skeletal muscle. During our PRRS infection studies, we do not see any major upregulation due to disease of proteolysis pathways in the skeletal muscle. In other words, we would reject the hypothesis that the pig is actually mobilizing extensive amounts of amino acids from lean tissue to support liver and other immune processes. We don't see the proteolysis machinery upregulated in the multiple proteolysis pathways we looked at. And so like a lot of the work that's been done out of the Baylor College of Medicine looking at inflammation challenges with endotoxin and fractional synthesis rates, we really see that health challenges seem to be more focused on the synthesis side of things than rather on compared to the degradation turnover side of things. We also saw no differences in reactive oxygen species production. I didn't show that data here. We isolated mitochondria. We looked at some markers of oxidative stress, and we don't see any differences in lean tissue that could explain the severe phenotypes that we saw. And so we're kind of ticking off a few areas that we say may not necessarily be the most appropriate areas to challenge from a pig metabolism standpoint. And we really think that diet and appetite needs to be targeted to help the pig resolve the health challenge. The other thing that I'll say outright, and I got no problem saying this, that during a peak infection with either bacteria or viruses, no matter what we do from a nutritional standpoint during that peak period, it's not going to do anything. Now there is some opportunities with the kind of antimicrobial side on the prevention side of things, but if a pig is going to get a full-blown virus challenge or bacteria challenge, nutrition is not a pharmaceutical, it is not going to do anything. So we shouldn't kid ourselves. Now, can it actually reduce the actual impact? Yes, it can. But it's not going to actually be the same as what an antibiotic or a drug. And so I think there's opportunities from a nutrition standpoint to help support the pig resolve that challenge efficiently. And then also, I think we can do more on the appetite side to help that pig grow through the challenge. And then hopefully at the end of this year, we'll tell you more about appetite stimulation, because we're trying to do a study in October to actually look at this. So we'll hopefully PRRS infect pigs and actually try and stimulate appetite. And so with that, I want to give a big thanks to Wes Schweer for his master's and PhD work. Also Shelby Curry and Emma Helm and Carson DeMille. These have been the grad students, 2 of them are now left, that have actually done most of this work. And we couldn't do all this work without them, as well as a big list of collaborators both at the vet school, industry, and also funding from National Pork Board, in particular the USDA, United Soybean Board and Iowa Pork Producers, and MASH-offs for supplying the work. More than happy to answer questions. I don't know how much time's left, but thank you very much for your attention.